Welcome to AR Maths Pro Learning Academy. In this video, I'm going to talk about inverse trigonometric functions of class 12 mathematics. Exercise 2.2 explanation of all solutions. Exercise questions from 1 to 15. Let us begin with introduction of inverse trigonometric functions. The basic introduction is you should know the domain and range of inverse trigonometric functions. These are 6 inverse trigonometric functions and their domains are here and ranges are here. Ranges all about principal values only. And some properties that you have to save. The first 6 properties are very useful, which we used in exercise 1.1. Question 1. We have to prove this following. 3 sine inverse x is equal sine inverse 3x minus 4 sine cube x, where x belongs to negative half to half. Let us consider first of all the right side part and we will try to get left hand side part. So this is our right hand side part, which I wrote it here. Try to see here, it is sine inverse. So here I must get some sine value so that sine inverse I can cross out. So I consider put x as sine theta. So in place of x, I will write sine theta. X cube means sine cube theta, like this. I plug in place of x, I wrote sine theta, and x cube, I wrote sine cube theta. Now, this is in the form of sine 3 theta. Trigonometric formula, sine 3 theta is 3 sine theta minus 4 sine cube theta. So, in place of all these, I will write sine 3 theta. Now, check. I can cross out sine inverse and sine. The remaining is 3 theta. Remember, if you cross out this sine inverse and sine, this 3 theta must follow this range, sine inverse range, which is negative pi by 2 to pi by 2. And whereas theta as sine inverse x, because if I want theta, this sine will go to the other side, so it becomes sine inverse. So in place of theta, I will write sine inverse x. So that final answer is sine inverse x, 3 sine inverse x, which is our left hand side part. Still, we have to prove that this 3 theta lies in this range. What is given? Given thing is x belongs to negative half to half. So I can write like this. X lies in between negative half to half. So negative half is less than or equal x, less than or equal to 2. Whereas x here is sine theta. So in place of x, I will write sine theta. It will be like this. Now, I don't want sine. So I will multiply sine inverse throughout the inequality, like this. So here, check here, sine inverse of sine theta is nothing but theta only. Sine inverse of sine theta is nothing but sine theta. Sorry, theta only. Sine inverse of negative half and sine inverse of half. Now we know that sine inverse of negative theta, this is first property, sine inverse of negative theta is nothing but negative sine inverse theta. So I can rewrite this sine inverse of negative half, I can write like negative sine inverse half, like this. And the remaining part I wrote as it is. Now, at what value of sine I get, at what angle of sine I get half. At sine 30, it is half. So in place of half, I can write sine pi by 6, which is 30. Here also, half, I can replace it by sine pi by 6, like this. See here, in place of half, I wrote sine pi by 6 and sine pi by 6. So here, you can cross out this sine inverse and sine. Remaining is negative pi by 6. And here also sine inverse and sine. So remaining inequality is like this: negative pi by 6 and theta as it is, here pi by 6. This theta lies in between negative pi by 6 to positive pi by 6. But we need 3 theta. We need 3 theta. So multiply the inequality by 3, like this. So here 3 times 1 and 3 times 2. Here also 3 times 1 and 3 times 2. It will be negative half, negative pi by 2. Check. 3 theta lies in between negative pi by 2 to pi by 2. This is what we have to prove, no? That's it. Question 2. 3 cos inverse x is equal cos inverse 4x cube minus 3x, where x lies between half and 1. Consider the right hand side part. In this place, I must get cos, so that this cos inverse and this cos will get cancelled. That's why I put x as cos theta. In place of x, I will write cos theta. If it is x cube, I will write cos cube theta. It will be like this: 4 cos cube theta minus 3 cos theta. From the trigonometric formulas, 4 cos cube theta minus 3 cos theta is nothing but cos 3 theta. So in place of all these, I will write cos 3 theta. It will be like this. Now, I can cross out cos inverse and cos. But this 3 theta must lie the range of cos inverse. This 3 theta must lie in between 0 to pi. Then only we can cross out this cos inverse and cos. So the remaining part is 3 theta. Where theta is, from the given part, from the considering part, where theta is cos inverse x. So in place of theta, I will write cos inverse x. So it will be 3 cos inverse x, which is our left hand side part. We proved. But still we have to prove that this 3 theta lies in this range. Lies in this range, cosine inverse x. So what is given? X lies between half and 1. X lies between half and 1. Whereas x is cos theta. So in place of x, I will write cos theta. So half is less than or equal to cos theta and less than or equal to 1. Now, multiply cos inverse throughout this inequality so that this cos and cos inverse will get cancelled. We need theta only, that's why. So cos inverse of half is less than or equal to theta is less than or equal to cos inverse 1. Now, at what angle cos will get half? Which is at cos 60, it is half. And at what angle of cos I'll get 1? Cos 0 is 1. Cos 0 is 1. So in place of 1, I will write cos 0, and in place of half, I will write cos pi by 3. It will be like this. Now we can cross out cos inverse cos, and cos inverse cos has gone. So the inequality is pi by 3 is less than theta and less than 0. But this inequality contradicts because 60 is less than theta and theta is less than 6. So rewrite this inequality in the greater form. Pi by 3, which means 60, is greater than or equal to theta, and theta is greater than or equal to 0. Now this is the rewritten inequality. Now multiply 3 throughout the inequality. Why? Because we need to know this 3 theta lies between which angle. So if I multiply 3 throughout this inequality, it will be like this. So that this 3 and this 3 gets cancelled, and 3 times 0 is 0. 3 times 0 is 0. So pi, here in this one I get only pi, is greater than or equal to pi, theta times 3, it is 3 theta. is greater than 0. So this 3 theta lies in between 0 and pi. Check. 0 and pi, which is proved. Question 3. We need to solve this question in simplest form. That's it. Remember, every question, if you have tan inverse, sine inverse, cos inverse, try to get here the same trigonometric ratio, so that inverse term and tan term gets cancelled. So that is why I put x as tan theta. So in place of x, I will write tan theta, and in place of x square, I will write tan square theta. So this part is going to be like this. Check out. In place of x, I wrote tan theta. In place of x square, I wrote tan square theta. In place of x, I wrote tan theta. Minus 1 as it is. Now, by using the identity, 1 plus tan square theta is equal to secant square theta. But here I have square root. So this square gets cancelled. Square root and gets cancelled. So square root of 1 plus tan square theta is nothing but secant theta. So I'm writing like this. Square root of 1 plus tan square theta is nothing but secant theta. Minus 1 as it is and tan as it is. Now, this tan and secant tried to switch in terms of sine and cosine. So secant I can write as 1 over cosine, and tan I can write as sine over cosine. So in place of secant, I will write 1 over cosine, and in place of tan, I will write sine over cosine. In the numerator part, take the LCM as cosine theta. So 1 minus cosine theta over cosine theta. It will be like this. Here, you can cross out the denominators part. Cosine theta and cosine theta gets cancelled. So tan inverse 1 minus cos theta by sine theta. Now, we have some trigonometric formulas. Cosine 2 theta in terms of sine theta, it is 1 minus 2 sine square theta. If I rewrite this formula in terms of 1 minus cos theta, this 2 sine square theta will go to the right. It will be like this. Check. 2 sine square theta is equal 1 minus cos 2 theta. But here I have 1 minus cos theta. Here I have 2 theta. So do one thing. Divide the angle by 2. If it is theta by 2, here 2 gets cancelled. Check. Here 2 gets cancelled. Here it will be 1 minus cos theta. So in place of 1 minus cos theta, I can write 2 sine square theta by 2. And in the denominator, sine theta is there. We have a formula. Sine 2 theta is nothing but 2 sine theta cos theta. But here I have single theta. Check. In the denominator, I have single theta. So that's why you have to write divide by 2. Angles has to be divided by 2. So this 2 gets cancelled. So sine theta, I can rewrite the formula like this. Sine theta is equal to 2 sine theta by 2 and cos theta by 2. So I will plug in these two formulas in this tan inverse 1 minus cos theta by sine theta. It will be like this. Check. 2 sine square theta by 2 over 2 sine theta by 2 cos theta by 2. So here 2 and 2 gets cancelled. Numerator and denominator gets cancelled. And here sine square theta by 2 square term and sine theta by 2 term will get cancelled. The remaining part is in the numerator it is sine theta by 2 and in the denominator cos theta by 2. It will be like this. Tan inverse sine theta by 2 cos theta by 2. So sine by cos I can write tan theta by 2. We have the formula. So tan inverse tan theta by 2. Now I can cross out this tan inverse and tan, but this theta by 2 must lie in the range of tan inverse, which is negative pi by 2 to pi by 2. So here tan inverse gone. The remaining part is pi by 2, theta by 2. Whereas theta from the considering part, theta is tan inverse x. So it will be 1 by 2 tan inverse x. In place of theta, I wrote tan inverse x. Now, since x is not equal to 0, which is given, since x is not equal to 0, and x is tan theta, so tan theta is not equal to 0. Tan theta must not be equal to 0, which means theta should not be equal to 0, because tan 0 is 0. Tan 0 is 0, since tan 0 value is 0. So theta should not be equal to 0. So theta lies between negative pi by 2 to pi by 2, which is tan inverse range, okay? Negative pi by 2 to pi by 2, except 0, okay? Theta lies between negative pi by 2 to pi by 2, but not 0. But here we have theta by 2, so divide this by 2. So theta by 2 should lies in between negative pi by 4 to pi by 4, except 0. That's all. Question 4. Tan inverse square root of 1 minus cos x over 1 plus cos x. Again, I told you, we have to switch this part inside the parenthesis to tan x or tan x by 2, whatever so that tan inverse and tan will get cancelled. We know that 1 minus cos theta is nothing but 2 cos square theta by 2, and 1 plus cos theta is 2 cos square theta by 2. So in place of 1 minus cos theta, I will write 2 sin square theta, and in place of 1 plus cos theta, I will write 2 cos square theta by 2, like this. So here 2 and 2 gets cancelled in the numerator, and in the denominator 2 and 2 gets cancelled, okay? And we know sin theta by cos theta is nothing but tan theta. So here sin square theta, cos square theta, which means tan square theta by 2. It will be like this. And this is square and square root you can cross out. It will be gone. So tan inverse tan x by 2. Now I can tan inverse and tan it can be gone if x by 2 the range, if x by 2 lies in between the range of tan inverse x, and the tan inverse x range is negative pi by 2 to pi by 2. So tan inverse gone, and x is pi by 2, x by 2. Now we have to prove that this x by 2 lies in this range. So the given part is x lies between 0 to pi, which is given, okay? But we need to know x by 2. So divide the inequality by 2. So 0 by 2 is less than x by 2 less than pi by 2. 0 by 2 is nothing but 0 is less than x by 2 is less than pi by 2. Check. X over 2 lies in between 0 to 90, which means it is the range, it is in the range of tan inverse x. So x belongs to x over 2 lies in between this range, tan inverse range. That's all. Question 5. Tan inverse cos x minus sin x over cos x plus sin x. Here, check. Tan inverse is given, so this part I must make tan x or tan x by 2 something, so that tan inverse and tan will get cancelled. So at first I took cosine x as common from the numerator as well as in the denominator. It will be like this. Check. I took cosine x common, so 1 minus sine over cosine, and it is 1 plus sine over cosine. Check. If you multiply cosine, it will be like this. And here you can cross out cosine x over cosine x, because both terms are in the numerator and denominator. You can cross out. And we know that sine over cosine is tan. So in place of sine x over cosine x, I will write tan. So it will be like this. Tan inverse 1 minus tan x over 1 plus tan x. It will be like this. Now, consider this part like this. We know that tan of a minus b is equal to tan a minus tan b over 1 plus tan a tan b. Consider a as pi by 4 and b as x. I want to get this part. That's why I'm doing this one. x as pi by 2, a as pi by 2 and b as x. It will be like this. The formula will be like this. Tan pi by 4, which is 45, 1. Tan pi by 4 is 1. So here also 1, here also 1. So this tan pi by 4 minus x is equal 1 minus tan x over 1 plus tan x. So in place of 1 minus tan x over 1 plus tan x, I can write tan of pi by 4 minus x. So in this part, I will write tan of pi by 4 minus x like this. Now I can cross out this tan inverse and tan, but this pi by 4 minus x must lies the range of tan inverse x. Okay, so the remaining part is pi by 4 minus x, and the range of tan inverse x is negative pi by 2 to pi by 2. We have to show that this theta, this angle, lies in between this range. How can I prove it? By given part. Given that pi by 4 is less than x and less than 3 pi by 4, like this. Multiply this inequality through negative sign. So if I multiply the negative sign, check, this less than will become greater than. It will be like this. So pi by 4 is greater than negative x, which is greater than negative 3 pi by 4. I got negative x. Now I need to add pi by 4. Add pi by 4 throughout the inequality, like this. Check, pi by 4 is there. I'd add pi by 4 here. Add pi by 4 minus x, pi by 4 minus 3 pi by 4. Now pi by 4 plus pi by 4 is 2 pi by 4. And this is negative 2 pi by 4 because the denominators are the same. So pi minus 3 pi is nothing but negative 2 pi. Now here 2 times 1 and 2 times 2. And here also 2 times 1 and 2 times 2. It will be pi by 2 is greater than pi by 4 minus x greater than negative pi by 4. Check, this angle pi by 4 minus x lies in between negative pi by 2 to pi by 2, which is the range of tan inverse x. That's all. Question 6. Tan inverse x over a square minus x square. Now again, you have to rewrite this one in such a form that tan inverse and tan will get cancelled. At first, put x is equal to a sine theta. A sine theta. So it will be tan inverse a sine theta by square root of a square minus a square sine square theta, because here x square is there. So in place of x, I am writing a sine theta. So if it is x square, I will write a square sine square theta. And in the denominator, I will take a square as common. And 1 minus sine square theta, by using the first identity of trigonometric identity, it is cos theta. And this a square and square root, yani a will comes out. It will be like this. Check, a square, it is under the square root, it comes a, and square root of 1 minus sine square theta is nothing but cos theta, by using the first trigonometric identity. Here numerator is a and the denominator is also a, so you can cross out. And sine theta over cosine theta is nothing but tan theta. Now tan inverse and tan will be gone if theta lies in the range of tan inverse x. Okay, whereas tan inverse range is negative pi by 2 to pi by 2. And theta is, at first you have to divide it by divided by a and a. So here a and a gets cancelled. It is only sine theta. So theta is sine inverse of x by a. It will be like this. Theta is Theta is sine inverse x by a. Now, check. We have to prove this theta lies in this range. It is given that modulus of x is less than a, which means x lies between positive a to negative a, negative a to positive a, whatever so. And the value of x is a sine theta. We know it. So in place of x, I will write a sine theta. In place of x, I will write a sine theta. So negative a is less than a sine theta, less than a. Divide the inequality by a. If I divide the inequality by a, it will be negative 1. A gets cancelled. Here only sine theta. A over a is nothing but 1. Now, multiply sine inverse throughout the inequality. Sine inverse of minus 1 is less than theta because sine inverse of sine theta is theta. And sine inverse of 1. We know that sine inverse theta is negative sine inverse theta. So here, negative sine inverse 1 is less than theta, less than sine inverse 1. Like this. And we know the value, at what angle of sine will get 1 is sine 90 is 1, pi by 2. So in place of 1, I will write sine pi by 2. In place of 1, I will write sine pi by 2, like this. And here sine inverse and sine will get cancelled. It will be negative pi by 2 less than theta. And here also sine inverse and sine will be gone. It is pi by 2. So theta lies in between negative pi by 2 to pi by 2, which is the range of tan inverse x. That's all. Question 7. Tan inverse 3a square x minus x cube over a cube minus 3a x square. We have to rewrite this part in such a way that we should get tan. So tan inverse and tan will be gone. And angle must be lies in between the range of the tan inverse. That's why I put x as a tan theta. So in place of x, I will write a tan theta. If it is x square, a square tan square theta. If it is x cube, a cube tan cube theta. It will be like this. In place of x, a tan theta. X cube, a cube tan cube theta. X square, a square tan square theta. Now here a square and a will be a cube. And here a multiplied by a square, it will be a cube again. So it will be like this. In the numerator, I can take a cube as common. So it will be, the remaining part is 3 tan theta minus tan cube theta over, in the denominator, I'm going to take a cube again as common. So that here in the numerator it is a cube and in the denominator it is a cube. You can cross out. Remaining part is this one. And we know that tan theta is nothing but 3 tan theta minus tan cube theta over 1 minus tan square theta. This is the formula of tan. So I can write tan 3 theta. Sorry, this is tan 3 theta. Okay. Tan 3 theta is equal to 3 tan theta minus tan cube theta over 1 minus tan square theta. Now I can cross out tan inverse and tan. But this 3 theta must lie in the range of tan inverse x. And the tan inverse of x is negative pi by 2 to pi by 2. Now, theta is nothing but, from here, theta is nothing but, if I divide a on both sides, a here as well as here, here a and a cross out. So theta is tan inverse x over a. It will be like this. Theta is nothing but tan inverse x over a. So it will be 3 tan inverse x over a. Now we have to prove that this 3 theta lies in this range. First of all, what is given? X lies in between negative a over root 3 and a over root 3, positive a over 3. And we know that x is a tan theta. X is a tan theta. So in place of x, I will write a tan theta. It will be like this. Divide a throughout the inequality. So this a and this a and this a will be gets cancelled. It will be negative 1 over 3 less than tan theta and less than 1 over root 3. I have to remove this tan, so multiply throughout the inequality by tan inverse. So it will be tan inverse negative 1 over root 3. Tan inverse of tan theta is theta. And tan inverse 1 over root 3. We know that tan inverse of negative theta is negative tan inverse theta. Tan inverse of negative theta, it is negative tan inverse x. Tan inverse theta. And this part is remains same. At what angle of tan we get 1 over root 3, which is tan pi by 6. Tan 60 is 1 over root 3. Sorry, tan 30 is 1 over root 3. So in place of 1 over root 3, I am writing tan pi by 6. So tan inverse tan will be gone. It will be negative pi over 6 less than theta. And tan inverse gets cancelled. It is pi over 6. So theta lies in between negative pi over 6 to pi over 6. But we need 3 theta. So multiply this inequality through by 3. So if I multiply it by 3, it will be negative pi over 2, because 3 over 6 is 1 over 2. That's why. So this 3 theta lies in between negative pi by 2 to pi by 2, which is the range of tan inverse x. Check. That's all. Question 8. Find the values of each of the following. In this question, tan inverse 2 cos 2 sin inverse 1 over 2. First, I consider this part, sin inverse half. What is the value of this one? I will plug in and then solve the remaining part. So consider sin inverse half. And we know the range of sin inverse x is negative pi by 2 to pi by 2. Let x is equal sin inverse half. At what angle of sine it will be half? That is sin pi by 6. Sin 30 is half. So in place of half, I'm going to write sin pi by 6. It will be like this. And sin inverse sine will be gone, and x is equal pi by 6. Look, this pi by 6 lies in between this range. So sin inverse half is pi by 6. So in place of sin inverse half, I will write pi by 6 like this. 2 is 2, and sin inverse of half is pi by 6. And 2 times 1 and 2 times 3 is 6, right? So it will be like this. Tan inverse 2 cos pi by 3. And what is the value of cos pi by 3? Pi by 3 means 60. Cos 60 is half. Okay? Cos pi by 3 is half. So I will write 2 times half, because cos pi by 3 is half. So here 2 times 1 and 2 times 1 gets cancelled. It is tan inverse 1 only. At what angle of tan? It will be 1, which is tan 45, tan pi by 4. So in place of 1, I will write tan pi by 4. And here tan inverse and tan I can cross out, which is pi by 4 is our answer. And we know that the range of tan inverse x is negative pi by 2 to pi by 2, which is in between this pi by 4 in this range above. Okay. Question 9. Tan of 1 over 2 sin inverse 2x over 1 plus x square plus cos inverse 1 minus it is y square over 1 plus y square. Now you have to consider this part so that it will get sine something, so that sin inverse and sine gets cancelled. In this also you have to get something here, cos something, so that cos inverse and cos will get cancelled. That is why I consider or put x as tan theta and y as tan phi. So in place of x, I will write tan theta, and in place of y, I will write tan phi. So this will be like this. In place of x, I wrote tan theta. If it is x square, I wrote tan square. If it is y square, I will root tan square phi. Y square tan square phi. It will be like this. And we know sine 2 theta is 2 tan theta by 1 plus tan square theta. And cosine 2 theta is 1 minus tan square phi by 1 plus tan square phi. So in this place, I will write cosine 2 phi, and in this place, I will write sine 2 phi. It will be like this. So here, sine inverse and sine will get cancelled. Remaining is 2 theta plus cos inverse and cos will get cancelled. Remaining is 2 phi. It will be like this. Tan of 1 over 2, 2 theta plus 2 phi. Take 2 as common in this parenthesis. Then it will be like this. And this numerator 2 and denominator 2 you can cross out. Okay. So it will be tan theta plus phi. This is in the form of tan of a plus b. And we know the trigonometric formulas. Tan of a plus b is nothing but tan a plus tan b by 1 minus tan a tan b. So this I'm going to rewrite like this. Tan theta plus tan phi over 1 minus tan theta tan phi. And we know tan theta is x and tan phi is y. So I replace all these. So my final answer is x plus y over 1 minus xy, because tan theta is x and tan phi is y. That is our final answer. Question 10. Find the values of each of the following expressions. Sine inverse of sine 2 pi by 3. I cannot cancel it, sine inverse and sine. It cannot goes out, because 2 pi by 3 is 120, which is not in the range of sine inverse. We know that the range of the sine inverse is negative pi by 2 to pi by 2, from negative 90 to positive 90. But this is 120. So I cannot cross out sine inverse and sine. That is why I have to rewrite this sine 2 pi by 3 in such a way that angle comes in this range. So that is why I wrote sine inverse of sine pi minus pi by 3. Check pi minus pi by 3. If you take the LCM, it is 3, 2 pi by 3. So 2 pi by 3 I can write in this way, pi minus pi by 3. Pi is 180 minus theta. 180 minus theta is in second quadrant, and in the second quadrant sine is there. And 180 is unchanged, so sine remains same. So the answer is sine pi by 3. Sine inverse of sine pi by 3. Now check sine inverse of sine can be dropped, because pi by 3 is 60, which is in this range. So the final answer is pi by 3, which is in the range of sine inverse x. Question 11. Tan inverse of tan 3 pi by 4. Look, I cannot cross out sine inverse, tan inverse and tan, because 3 pi by 4 is 135. 135 is not in the range of tan inverse x, because the range of the tan inverse x is negative pi by 2 to pi by 2, which means negative 90 to positive 90. But this is 135, which is not in this range. So you have to rewrite this tan 3 pi by 4 in such a way that it comes in this range. So I wrote 3 pi by 4 as pi minus pi by 4. Check, if I take the LCM, it is 4 minus pi. 4 pi minus pi is 3 pi by 4. And 180 minus theta is in the second quadrant. 180 minus theta is in the second quadrant. But in the 180 minus theta is in the second quadrant, but in second quadrant it is sine and cosecant is there, but tan is not there. And 180 pi is unchanged, so tan remains same, but with the negative value. It will be tan inverse of negative tan pi by 4. Negative tan pi by 4. Why negative sign? Because in the second quadrant tan is not there. That is why we have to put negative sign. Negative tan pi by 4 I can rewrite as tan negative pi by 4, because we know that tan of negative theta is negative tan theta. So negative tan pi by 4 I can rewrite as tan of negative pi by 4. Now this negative pi by 4 is negative 45, which is in this range. So tan inverse and tan, it can be dropped. And the final answer is negative pi by 4, which is in the range of tan inverse x. Check. Negative pi by 4 is negative 45, which is in this range. Question 12. Tan of sine inverse 3 over 5 plus cot inverse of 3 over 2. At first, consider x as sine inverse 3 over 5 and y as cot inverse 3 over 2. So this expression will be tan of x plus y. It will be like this. And we know tan of x plus y is tan of a plus b, tan a plus tan b by 1 minus tan a tan b. So it will be tan x plus tan y over 1 minus tan x tan y. Now we have to get the values of tan x and tan y. From where? From these equations I will get it. Let us first consider about x is equal sine inverse 3 over 5. If I switch this sine inverse over there, it will be sine x is equal 3 over 5. Sine x is equal 3 over 5, and we know the sine is opposite over hypotenuse. Opposite over hypotenuse. So here opposite is 3, so this side is 3, and hypotenuse is 5. I have to find adjacent. To find adjacent by using Pythagoras, I can find adjacent, which is nothing but square root of c square minus b square, 5 square minus 3 square, which is square root of 16, and square root of 16 is nothing but 4. So the adjacent side is 4. So sin x is 3 over 5. Similarly, I can find tan x as 3 over 4 because tan is opposite over adjacent. I got tan x value. Similarly, I have to consider y is equal cot inverse 3 over 2. If I switch cot inverse on the left, it will be cot y equal 3 over 2. And we know cot is adjacent over opposite. I can easily find tan y. How can I find tan y? Tan is opposite over adjacent. So it will be 2 over 3. So tan y is 2 over 3 and tan x is 3 over 5. So in place of x, tan x, I will write 3 over 4. And in place of tan y, I will write 2 over 3. It will be like this. In the numerator, I took 12 as the LCM. 12 as the LCM. Check. I wrote 12. And 12 divided by 3 is 3. Sorry, 12 divided by 4 is 3. And 3 times 3 is 9. And positive sign as it is. 12 divided by 3 is 4. 4 times 2 is 8. In the same way, in the denominator part, I took 12 as the LCM. And 12 divided by 1 is 12. And 12 times 1 is 12. Minus 12 divided by 12 is 1. 1 times 6 is 6. So here the numerator part of denominator and denominator part of denominator will be the same, and I can cross out. So the final answer is 8 plus 9 is 17 and 12 minus 6 is 6. That is our final answer. Question 13. Cos inverse cos 7 pi by 6 is equal these options. Now check that 7 pi by 6 is 210. Which is not in the range of cos inverse, because I know the cos inverse range is 0 to pi. And this 7 pi by 6 is 210, which is not in this range. So I have to rewrite this in such a way this angle will come in this range. So cos inverse 7 pi by 6 I can write as cos 2 pi minus 5 pi by 6. Check. If I take the LCM, I got 6. 6 times 2 is 12. 12 minus 5 is 7. And I took 2 pi because 2 pi is 360 minus theta. 360 minus theta is in the fourth quadrant. And in the fourth quadrant, cosine is there. So this one is positive directly. So cos 2 pi minus 5 pi by 6 is cos 5 pi by 6. 2 pi is 360, which is unchanged. So cosine will be the same cosine. So it will be cosine inverse of cosine 5 pi by 6. Now, what is 5 pi by 6? Try to understand. 5 pi by 6 is nothing but 150, which is in this cosine inverse range. Now, I can cross out cosine inverse and cosine. The final answer is 5 pi by 6, which is option B. Question 14. Sine of pi by 3 minus sine inverse of negative half is equal. We have four options. At first, what is given, I write it. And we know that sine inverse of minus theta is minus sine theta. Sine inverse of minus theta is minus sine inverse theta. So this negative sign and this negative sign will become positive. So sine of pi by 3 plus, that is why it is plus, because I have negative sign in the question, and negative sine inverse of negative theta is negative sine theta. So this negative and this negative will be positive. Sine inverse half. Now consider this part only. What is the value of sine inverse half? What is the value of sine inverse half? We know that the range of the sine inverse is negative pi by 2 to pi by 2. Let x is equal sine inverse half. At what angle sine is half is sine pi by 6. Sine 30 is half. So in place of half, I will write sine pi by 6 like this. And sine inverse sine will be gone, and pi by 2 is in the range of sine inverse x. So x is pi by 6. So sine inverse half is nothing but pi by 6. So in place of sine inverse half, I will write pi by 6 like this. Sine of pi by 3 plus pi by 6. Now the LCM is 6. The LCM is 6. And here it will be 6 divided by 3 is 2. 2 times pi is 2 pi. Plus is there, plus 6 divided by 6 is 1. 1 times pi is pi. So 2 pi plus pi is 3 pi by 6. Sine of 3 pi by 6. 3 times 1 and 3 times 2. It will be sine pi by 2. Sine pi by 2 is nothing but 90. Sine 90 is 1. So the final answer is option A. Question 15. Tan inverse square root of 3 minus cot inverse of negative square root of 3 is equal. We have four options. At first, this is given. Okay. And we know that cot inverse of negative theta or negative x is pi by 2 minus cot inverse x. Okay. So in place of cot inverse negative root 3, I will write pi minus cot inverse root 3. This part. And this part I'm going to write it as it is. Like this. This negative sign is there, I wrote negative sign. Cot inverse of negative pi by 3 is pi minus cot inverse root 3, square root of 3. Now, at what value of tan, it will be root 3. It is tan pi by 3. Tan 60 is root 3. And at what value of cot, it is root 3. It is cot 60. Cot 30, sorry. Cot 30 is root 3. So in place of root 3, I will write tan pi by 3. And in place of this root 3, I will write cot pi by 6. Like this. Now, tan inverse and tan I can cancel. But this pi by 3 must be the range of tan inverse x. And we know the range of the tan inverse x is negative pi by 2 to pi by 2. As well as I can cross out cot inverse and cot. But this pi by 6 must be in the range of cot inverse x. And we know the range of cot inverse x is 0 to pi. So both of them are in these ranges. So I can cross out. The answer is tan inverse tan gone, pi by 3. Minus is there, minus, pi is there, pi, and cot inverse cot is gone, pi by 6. Now, if I multiply this negative sign throughout the parentheses, I got pi by 3 minus pi plus pi by 6, because negative with negative, positive. Now, the LCM of this one is 6. So 6 divided by 3 is 2. 2 times pi is 2 pi. And here, in the denominator, if I don't have, I have 1. So 6 divided by 1 is 6. 6 times pi is 6 pi. Negative sign is there, negative sign. 6 divided by 6 is 1. 1 times pi, pi. Now, pi minus 6 pi plus pi is nothing but negative 3 pi by 2. And 3 over 6 is nothing but half, 1 over 2. So the answer is negative pi by 2, which is option B. This is the end of exercise 2.2 of inverse trigonometric functions. And if you have learned something new today, hit the like button, share with your friends and family, and don't forget to subscribe. Thank you.